Hey there, and welcome to VCE Master Academy. I am so glad you are here. Today we are starting Unit 2 with something that sounds fancy but is really friendly once you meet it. The Unit Circle and Radians. Don't worry if this looks hard, we'll make it simple, step by step. Let us start with radians. You already know one way to measure angles: degrees. A full turn is 360 degrees. Radians are just another way to measure the same angles. The way mathematicians love because it makes the formulas beautiful. Here is the idea. Take the radius of a circle and bend it along the edge of the circle. The angle that this bent radius makes at the center is exactly 1 radian. That is it. And if you wrap the radius all the way around the circle, it fits exactly 2 pi times. So, 1 full turn is 2 pi radians, and that is the same as 360 degrees. Half a turn, pi radians, is 180 degrees. So to switch between them, remember one line. Pi radians equals 180 degrees. To turn degrees into radians, multiply by pi over 180. To turn radians into degrees, multiply by 180 over pi. Easy swap. Now 2 more gifts from radians. First, arc length. The arc is just the curved piece of the edge of the circle. Its length is simply L equals R times theta, the radius times the angle in radians. Short and sweet. Second, the unit circle. This is a circle with radius exactly 1, sitting at the center of the axes. Pick any angle theta, draw the radius out to the edge, and the point where it lands has coordinates cosine theta across and sine theta up. So cosine is just the across value, and sine is just the up value. And tangent is simply sine divided by cosine. Sine, cosine, and tangent are functions. You feed in an angle and you get a number out. Let us picture it. Here is the unit circle. The angle theta opens from the positive x-axis, the radius reaches point P, and P is at cosine theta, sine theta. The flat distance is cosine, the height is sine. Keep this picture in your head. It is the whole topic in one drawing. Example 1. Nice and gentle. Converting angles. Part A. Convert 120 degrees into radians. We multiply by pi over 180. 120 times pi over 180. 120 over 180 simplifies to 2/3. So the answer is 2 pi over 3 radians. Part B. Convert pi over 6 radians into degrees. We multiply by 180 over pi. The pi cancels and 180 over 6 is 30. So pi over 6 is 30 degrees. Example 2. Medium. Arc length. A circle has radius 10 centimeters and the angle at the center is 3 pi over 4 radians. Find the length of the arc. We use L equals R theta. 10 times 3 pi over 4. 10 times 3 pi is 30 pi, divided by 4 is 15 pi over 2 centimeters. As a decimal, that is about 23.56 centimeters. Let us see that as a picture. Here is the sector, a slice of pizza. The 2 straight edges are the radius R. The angle between them is theta, and the curved crust is the arc, with length R times theta. Example 3. An ATAR style one. Reading the unit circle. A point P sits on the unit circle at the angle 2 pi over 3, which is 120 degrees. Find its coordinates and find tangent of the angle. The coordinates are cosine and sine of the angle. Cosine of 120 degrees is -1/2, and sine of 120 degrees is √3 over 2. So P is at -1/2 √3 over 2. It sits up and to the left in the second quadrant, and tangent is sine over cosine. √3 over 2 divided by -1/2, which gives -√3. Here it is on the circle. The angle 2 pi over 3 swings past the top into the second quadrant, and the point lands at -1/2 √3 over 2. Across is negative, up is positive, exactly what the signs told us. Where does this show up in real life? Think of a Ferris wheel with radius 20 meters. It turns through an angle of pi over 2 radians. That is a quarter turn. How far does your seat travel along the curve? Arc length again. L equals r theta, 20 times pi over 2, which is 10 pi, about 31.4 meters. So a quarter turn carries you more than 30 meters through the air. Radians and arc length, doing real work. Quick summary. A radian is the angle made when the arc equals the radius. One full turn is 2 pi radians, which is 360 degrees, and pi radians is 180 degrees. To convert, multiply by pi over 180 or by 180 over pi. Arc length is L equals r theta. On the unit circle, a pointed angle theta is cosine theta, sine theta, and tangent is sine over cosine. Now it is your turn. Pause the video and try these 5. 1. Convert 45 degrees into radians. 2. Convert 5 pi over 6 radians into degrees. 3. Find the arc length of a circle with radius 8 centimeters and a central angle of pi over 4 radians. 4. Write the coordinates of the point P on the unit circle at the angle pi. 5. Find tangent of pi over 4 using sine and cosine. Ready? Let us check them together. Question 1. 45 times pi over 180. 45 over 180 is 1/4, so the answer is pi over 4 radians. Question 2. 5 pi over 6 times 180 over pi. The pi cancels, and 180 over 6 is 30, times 5 is 150, so it is 150 degrees. Question 3. Arc length is r theta, 8 times pi over 4. 8 over 4 is 2, so the arc is 2 pi centimeters, about 6.28 centimeters. Question 4. The angle pi is half a turn, landing on the far left of the circle, so the point is cosine pi, sine pi, which is -1, 0. Question 5. Tangent of pi over 4 is sine over cosine. Both sine and cosine of pi over 4 are √2 over 2, and something divided by itself is 1, so tangent of pi over 4 is 1. Fantastic work! You just met the unit circle, radians, and the 3 circular functions, and you can already use them. Remember, you are mastering VCE Maths, one concept at a time. I will see you in the next lesson at VCE Master Academy.